The YAMAWA forest is a forest full of threading tools. The history of cutting threads has been ongoing since the Middle Ages. In the West, Leonardo da Vinci drew a diagram of a machine for cutting threads. In Japan, matchlock guns were introduced from Portugal in the 16th century. This began the history of cutting thread. Let's study about cutting taps this time. So, let's get started.
A tap is an external threaded tool that forms an internal thread in the bored hole by rotating and feeding in according to the lead of the tap's thread. Taps can be broadly divided into cutting taps and roll taps. This time we will introduce you to cutting taps. The cutting tap is divided into hand taps, spiral fluted taps, and spiral pointed taps according to the shape of the flute. So let's start with hand taps and go from there. Hand taps are characterized by their straight flutes and, as the name suggests, have a long history of being used by manually turning them by hand. Hand taps can be used for both blind holes and through holes due to its structure that stores the fine chips in the flute. There are three types of hand taps depending on the chamfer length: taper taps, plug taps, and bottoming taps. Hand taps have a very strong cutting edge, making them ideal for tapping hard materials and hard brittle castings. In addition, the straight flutes make them easier to be resharpened. As you can see, a tap with a helix flute is called a spiral fluted tap. Spiral fluted taps have helical flutes that eject the finely curled chips backwards out of the hole. This makes it suitable for tapping blind holes. Spiral fluted taps are suitable for threading sticky materials because of their sharpness. A tap with additional slanted flutes, called a gun shear flute at the end of the tap, is called a spiral pointed tap. The chips are pushed forward and ejected at the other end of the hole. It is suitable for machining through holes because it pushes chips forward. This results in better chip evacuation, and the shallow flutes make it less prone to breakage. Spiral pointed taps have relatively low torque and can be used on machines with lower horsepower. This section explains the 5 main parts of a tap and their functions. There's the chamfer, the full-threaded part, the flute, the shank, and the shank square. The chamfer is directly involved in the cutting of the internal thread as a cutting edge. The amount of material that each tool cuts is determined by the chamfer length and the number of flutes. The full thread enters into the thread cut by the chamfered part of the tap and serves as a guide as the tap continues deeper into the hole. Generally, taps have a certain amount of true circle from the cutting edge to maintain self-guiding properties. The flute forms the rake angle, which is the most important part of a cutting tool. It also plays a large role in the containment or discharge of the chips and the supply of cutting fluid. The shank is responsible for holding the tap in the chuck or holder. The square on the shank serves as a stopper to prevent the tap from spinning or falling out when it is attached to the holder. Tap materials are mainly divided between high-speed tool steel and cemented carbide. Generally, taps are made of SKH51 or SKH58 equivalent of molybdenum-based high-speed tool steel. Cobalt HSS is used for high-speed cutting, and powdered HSS is used for difficult-to-cut materials. Cemented carbides are used in the machining of heat-treated hard materials, ultra-high-speed machining of aluminum and cast iron, as well as in machining that requires increased durability. Surface treatment for taps includes oxidizing, nitriding, and PVD coatings. The black-colored surface treatment is called oxidizing. The purpose of this treatment is to prevent welding of steel materials and to improve the surface finish of the internal thread surface. The grayish surface treatment is called nitriding. A hard nitriding layer of 1000 HV or more permeates the surface of the tool, making it suitable for machining cast iron, aluminum die castings, etc., where wear resistance is required. Coatings are used for high-speed machining and longer tool life. Tap coatings include TIN, TICN, TIALN coatings, and others. That's all for now. In this article, I have explained about what is a cutting tap. There will be more in this series, so please stay tuned.